I'm Anil Kumar, and in this video we'll explore area under a curve. The question here is, write an expression for area of the function f of x equals to 2x plus 3 from 1 to x. So let me sketch this function here and then we are going to discuss about it. So let's say that's our coordinate axis, and this function, which is f of x equals to 2x plus 3, will have y-intercept at 3, and it's a straight line with slope of 2, right? So I could sketch this kind of like this. Let's say that's the function. Now what we need to find here is an expression for area of this function from 1 to x. So let us say this is 1 for us, right? Let's say this is 1, and let's take a general point x somewhere along the x-axis. So let me take x as somewhere here, okay? So this be any point x on the x-axis. Now if that is 1, then the value of the function here will be f of 1, and this point can be represented as x f of x, correct? Means value of the function at x, which is 2x plus 3 in general, right? When I say that we need to find an expression for area of the function, this from 1 to x, that means we are interested in this area, right? So we need to find area between the line and the x-axis. So that is what we are interested in finding. So that's the question. Okay. What we see here is that it is a trapezoid, and therefore we can actually find area of this trapezoid, and that should be equal to area of this function in this region, right? So this point is 3 for us. Okay. Now let me break this. Okay, it doesn't seems to be as per the scale. Anyway, so we can say that area of the function, which is f of x, when we are working from 1 to x, should be area of this trapezoid, right? So we can say the area of the trapezoid is, let's call these points as P and Q, and let us say that these points have corresponding values here as A and B. Let me write them as A and B, right? So okay, A and B. So we have a trapezoid here, which is so area of the function is equal to the area of trapezoid, which is, we can say APQB, correct? So that is a trapezoid where the parallel sides are PA and QB, and the height of this trapezoid is from A to B, that is x minus 1, right? So we can use all those things. So what we see here is that the height of this trapezoid will be this side, which is A to B, which is x minus 1. And the two parallel sides, these are the two parallel sides. So we can say A is equal to this length, PA, right? PA, which will be equal to f of 1, right? Which is f of 1. Now f of 1 really means that you have to substitute 1 here to get this value. So we can write this as 2 times 1 plus 3, and that is 5. So this we found as 5. Now B, the other parallel side length, is equal to QB, right? Is QB, which is equals to f of x, right? F of x in general, which is 2x plus 3 for us. Now we can apply the formula, right? So we can say that area of our function is equal to, as a function of x, is equal to area of trapezoid. Now what is area of trapezoid? It is half of height, right, which is x minus 1 for us, x minus 1, times a plus b. Let me write down the formula here first. Half of height times a plus b, right? Sum of these two sides, if this is a and this is b for us, is it okay? And that is the, we are saying height is h, which is kind of between these two. Is it okay now? So that is what area of trapezoid is. So this height is x minus 1. A and b, we just found these values. So it is 5 plus the general expression 2x plus 3, right? So that becomes the area for this particular trapezoid. So we can say half, and now we could actually write this as x minus 1. Simplify. 5 plus 3 is 8, so I can write 2x plus 8. Okay. Now we'll multiply. So we have half of 2x square plus 8x minus 2x minus 8, right? So that is half of 2x square, and 8x minus 2x is 6x minus 8, and that is equals to x square plus 3x minus 4, right? So that becomes the expression for the given function in interval 1 to x. Do you see that? So that is our solution, right? So we get the area as x squared plus 3x minus 4. So that's the solution to the question. Now here is a very interesting thing, and that is what is derivative of ax? What I'm trying to say is, what is a dash x? Let's figure that out, right? So what we will do here is, we know what a is, we'll try to see what is a dash. So a is this expression, a of x, right? A of x is x squared plus 3x minus 4. A dash x is derivative of this, which will be 2x plus 3. A dash x is 2x plus 3. Now, do you notice that it is exactly equal to the function? So which is equals to the function itself. So from here, you can say that the antiderivative of the function is the area. Do you see that? So from here, since we found that the derivative of the area is f of x, so we can say antiderivative of function. Now in this case, there is one thing very particular, that is, we're talking about when the function is positive and the function is continuous. So antiderivative of the function, so let me add that, when it is positive and continuous, right? So antiderivative of the function is area, or represents the area, right? So this is kind of a conclusion which we can draw from here, right? We can actually prove this also. In one of the videos we will do so, and then based on this we'll solve some questions. That should be very interesting. But I hope you get in concept. That is to say, if we have a function which is continuous, positive, in the interval, then the area expression is actually antiderivative of the function, because when you find derivative of that area expression, you get your function back. I'm Anil Kumar, and I hope you appreciate it. You can always share and subscribe to my videos. Thank you, and all the best.